Question number 24. A trapezium PQRS with vertices P 22, Q 62, R 64 and S 28 is mapped onto P prime, Q prime, R prime and S prime by a transformation matrix which is a 2 by 2 matrix -1 0 0 1. Part A, find the coordinates of P prime, Q prime, R prime and S prime. So we use the formula matrix multiplied by the object coordinates should give us the image coordinates. So we have a 2 by 2 matrix which is -1 0 0 1. We multiply by the object where the coordinates are 2 2 for P, then 6 2 for Q, 6 4 that is R and 2 8 S. This we will be able to get P prime, Q prime, R prime and S prime. The first row by the first column we have -1 multiplied by 2 plus 2 multiplied by 0 which gives us -2. First row, second column, we have -1 multiplied by 6 plus 2 multiplied by 0 which gives us -6. First row, third column, we have -1 multiplied by 6 plus 4 multiplied by 0 which gives us -6. First row and the fourth column we have -1 multiplied by 2 plus 8 multiplied by 0 which gives us -2. For the y coordinates we use the second row. So the second row by the first column we have 0 multiplied by 2 which is 0 plus 1 multiplied by 2 to give us 2. Second row, second column, 0 multiplied by 6 which is 0 plus 1 multiplied by 2 which is 2. Second row, third column, 0 multiplied by 6 which is 0 plus 1 multiplied by 4 which is 4. And lastly, the second row by the fourth column which is 0 multiplied by 2 to give us 0 plus 1 multiplied by 8 which is 8. So the coordinates of P prime will be -2 2. The coordinates of Q prime will be -6 2. Coordinates of R prime will be -6 4 and the coordinates of S prime will be -2 8. Part B, we are told on the grid provided draw PQRS and its image, that is P prime, Q prime, R prime and S prime. So we have our grid here. We will plot the coordinates of P which is 2 2, that is P. Q is 6 2. R which is 6 4. and lastly S, which is 2, 8. We join these points to make the trapezium PQRS. There you go. Now we plot the coordinates of P prime, Q prime, R prime, and S prime. And we have P prime at negative 2, 2. That is P prime. Q prime is at negative 6, 2. Q prime. We go to R prime, which is negative 6, 4. And lastly, S prime, which is negative 2, 8. Then we join these points to make the trapezium P prime, Q prime, R prime, and S prime. Part C, Roman 1, find P double prime, Q double prime, R double prime, and S double prime, which is the image of P prime, Q prime, R prime, S prime under the transformation matrix, which is N, given as negative half, 0, 0, negative half. So again, to get these coordinates, we have to use matrix multiplied by object to give us the image, and in this case our object will be P prime, Q prime, R prime, and S prime. Matrix by object to give us image, and our matrix is given as 0, negative half, 0, and 0, negative half, multiplied by the object, which is negative 2, 2, negative 6, 2, negative 6, 4, negative 2, 8. First row by first column, we have negative half multiplied by negative 2 plus 2 multiplied by 0, which will be positive 1. First row, second column, negative half multiplied by negative 6, that is negative half multiplied by negative 6 to give us positive 3, plus 2 multiplied by 0, which is 0, so here we'll have 3. First row, third column, negative half multiplied by negative 6, which is 3, plus 0 multiplied by 4, which is 0, so here we have 3. First row and the fourth column, we have negative half multiplied by negative 2, which is positive 1, plus 0 multiplied by 8, which is 0, so here we have 1. To get the y coordinates, we take the second row. So the second row by the first column is 0 multiplied by negative 2, which is 0, plus negative half multiplied by 2, which is negative 1. Second row by the second column, 0 by negative 6 is 0, plus negative half by 2, which is negative 1. Second row in the third column, negative 6 multiplied by 0, which is 0, plus negative half multiplied by 4, which is negative 2. And lastly, we have second row multiplied by the fourth column, which is 0 multiplied by negative 2 to give us 0, plus negative half multiplied by 8 to give us negative 4. So this means that the coordinates of P double prime are 1, negative 1, Q double prime 3, negative 1, R double prime 3, negative 2, and S double prime we have 1, negative 4. Roman 2, we are told that on the same grid, draw P double prime, Q double prime, R double prime, and S double prime. So we go to our grid to plot these points. So P double prime is 1, negative 1, Q double prime, which is 3, negative 1, R double prime, which is 3, negative 2, and S double prime, which is 1, negative 4. Then we join these points to make a trapezium. Part D, Roman 1, we are told to find a single matrix that maps P double prime, Q double prime, R double prime, and S double prime onto P prime, Q prime, R prime, and S prime. So we are going to use the formula matrix multiplied by the object to give us the image, where our object will be the double primes and the image will be the primes. So we let the matrix be a 2 by 2 matrix, which is A, B, C, D. Then we multiply by our object, which is the double primes, and we have 1, negative 1, 3, negative 1, 3, negative 2, and 1, negative 4. This should give us the image, which is our prime. So it's negative 2, 2, negative 6, 2, negative 6, 4, and negative 2, 8. First row, by the first column, we have 1 multiplied by A to give us A, plus 1 multiplied by B, which is negative, to give us negative B, which is equal to negative 2. The first row and the second column, we have 3 multiplied by A to give us 3A, plus B multiplied by negative 1 to give us minus B, is equals to negative 6. We solve these two equations simultaneously to find the value of A and B. So from equation 1, we can make A the subject of the formula, and we'll have A is equals to negative 2 plus b. Then substitute the value of a in equation 2. We have 3 into negative 2 plus b minus b is equals to negative 6. So open the brackets. We have 3 multiplied by negative 2, which is negative 6, plus b multiplied by 3, which is 3b, minus b is equals to negative 6. So 3b minus b is 2b. So we have negative 6 plus 2b is equals to negative 6. So 2b is equals to negative 6 plus 6, and 2b will be equal to 0, and this implies that the value of b is equal to 0. We substitute the value of b in this equation, and the value of a will be equal to negative 2. To get the value of c and d, we use the second row. So we have the second row multiplied by the first column to give us c multiplied by 1, which is c, plus d multiplied by negative 1, which is minus d, is equals to negative 2. We are taking this point, which is now 2. The second row by the second column is 3 multiplied by c, which is 3c, minus d, that is d multiplied by negative 1 to give us minus d, is equals to, we are taking this y coordinate, which is 2. Now we solve these two equations simultaneously to get the value of c and d. So we can make c the subject of the formula for the first equation, and this will be equal to 2 plus d. Then we substitute this value of c in equation 2, which will be 3 multiplied by 2 plus d, then minus d is equals to 2. We open the brackets, and this becomes 6 plus 3d minus d is equals to 2. So we have 6 plus 3d minus d, which is equal to 2. We collect the like terms together. We have 6 plus 2d, that is 3d minus d is 2d, is equals to 2. So 2d is equals to 2 minus 6. 2d will be equal to negative 4. Divide by 2, divide by 2, and the value of d will be negative 2. We can substitute the value of d in this equation to get the value of c. So we have c is equals to 2 plus d. This means that c is equals to 2 plus negative 2, that is 2 minus 2, which is 0, and the value of c will be 0. So the matrix of that transformation is equal to the value of a, which is negative 2, the value of b, which is 0, the value of c, which is 0, and the value of d, which is negative 2. Lastly, we are told to describe fully the transformation that maps p double prime, q double prime, r double prime, and s double prime onto p prime, q prime, r prime, and s prime. So if we compare these two, we have the double primes, which are being mapped onto the primes. You realize that it is a an enlargement with the center OO, which is the origin, and the enlargement scale factor is negative 2. So we say it is an enlargement center 0, 0, which is the origin, and the enlargement scale factor is negative 2.